Today's lesson is Arrhenius concept of acids and bases. That means, according to scientist Arrhenius, which compounds are acids and which compounds are bases. This is today's topic. In this lesson, we are going to learn a short biography of scientist Arrhenius, then Arrhenius acids with some examples, and Arrhenius bases with some examples. So let's begin. The very first point is a short biography of scientist Arrhenius. Scientist Arrhenius, the full name is Svante August Arrhenius. He was Swedish scientist, originally a physicist, but often referred to as chemist. He was one of the founders of the science of physical chemistry. He was the first Swedish Nobel laureate in chemistry in the year 1903. He was born on 19 February in 1859 in Bellingstad Church of Sweden. He was died on 2nd October in 1927 in Stockholm of Sweden. Lifespan was around 67 years. He was known for ionic dissociation of acid-base theory. This is a short biography of scientist Arrhenius. Let's see the next point. Now the point is Arrhenius acids and examples. Let's see some examples and then definition of acids according to Arrhenius theory. Hydrogen chloride, which is in gaseous state. This is Arrhenius acid. Sulfuric acid, which is liquid in state. Nitric acid, which is liquid in state. Hydrogen sulfide, which is gaseous in state. Hydrogen cyanide, gaseous in state at normal condition. Acetic acid, the state of acetic acid is liquid at normal condition. These are the examples of Arrhenius acids. Here one thing is observed that all the compounds have hydrogen. So definition of Arrhenius acid is the hydrogen containing compounds that give protons in water are called Arrhenius acids. Now let's see how these compounds produce protons in water. Hydrogen chloride, which is gaseous in state, when it is dissolved in water, then proton is produced, which is surrounded by aqua, that means water. At the same time, chloride ion is formed. This is also surrounded by aqua, that means water. Here, when suppose this is water and hydrogen chloride gas is dissolved here, this is hydrogen chloride, and after dissolving hydrogen chloride, the solution obtained is symbolized by HCl aqueous, that means hydrochloric acid. This is hydrogen chloride, and the acidic form of hydrogen chloride is hydrochloric acid. So this is the way in which hydrogen chloride gas produces proton in water. So hydrogen chloride gas is a kind of Arrhenius acid. Now the acid is nitric acid HNO3, which is liquid state at normal condition. When this nitric acid is added to water, then proton is formed surrounded by water, and nitrate ion is formed which is surrounded by water as well. Since this compound produces proton in water, so nitric acid is a kind of Arrhenius acid. Now let's see sulfuric acid H2SO4, which is liquid at normal condition. When it is added to water, then proton is formed. At the same time, sulfate ion is formed, which is surrounded by water. This proton is surrounded by water as well. Sometimes it is showed in this way, that is, this proton is added to water molecule and this ion is formed, which is called hydronium ion. So sulfuric acid is a kind of Arrhenius acid. Let's see some more acids. Now the compound is hydrogen sulfide, which is gaseous at normal condition. When it is dissolved in water, then it yields proton, which is surrounded by water, and another ion is formed, that is hydrosulfide ion. Hydrosulfide ion is formed. This is hydrogen sulfide. Its another name is sulfane. So hydrogen sulfide can produce protons in water. So hydrogen sulfide is a kind of Arrhenius acid. Let's see another acid, that is hydrogen cyanide, which is gaseous in state, and when it is dissolved in water, then proton is formed and cyanide ion is produced, which is surrounded by water. Now its name is hydrogen cyanide. But when this hydrogen cyanide gas is dissolved in water, then a solution is obtained. This is symbolized by hydrogen cyanide aqueous. Now its name is hydrocyanic acid. So hydrogen cyanide is a kind of Arrhenius acid because it can produce proton in water. Let's see another acid. Now the acid is acetic acid, which is liquid at normal condition. When it is dissolved in water, then this hydrogen is released as proton, which is called acidic hydrogen. It is released as proton, and another anion is formed, that is acetate ion. So acetic acid is a kind of Arrhenius acid because it can produce protons in water. Let's see the next point. Now the point is Arrhenius bases with some examples. Let's see some examples of Arrhenius bases, that is sodium hydroxide, which is solid at normal condition, potassium hydroxide, solid at normal liquid at normal condition. So these compounds are Arrhenius bases. One thing is observed here that all the compounds have hydroxide ion. This is hydroxide ion. So the definition is the compounds or hydroxide compounds that can produce hydroxide ion in water are called Arrhenius bases. Let's see how these compounds produce hydroxide ion in water. When sodium hydroxide is dissolved in water, then it ionizes and sodium cation is formed, which is surrounded by water. At the same time, hydroxide ion is formed, which is surrounded by water. So sodium hydroxide can produce hydroxide ion in water. So sodium hydroxide is a kind of Arrhenius base. Let's see about potassium hydroxide. Potassium hydroxide, which is solid at normal condition, when it is dissolved in water, then potassium ion is formed, which is surrounded by water. At the same time, hydroxide ion is formed, which is surrounded by water. So potassium hydroxide is a kind of Arrhenius base because it can produce hydroxide ion in water. Now let's see about ammonium hydroxide. Ammonium hydroxide, which is liquid at normal condition, when it is dissolved in water, then a very low percent of ammonium hydroxide is ionized and form ammonium ion. At the same time, hydroxide ion is formed. It's a kind of weak base, that is why percentage of ionization is very low, and for this reason here equilibrium arrow is used. So ammonium hydroxide is a kind of Arrhenius base because it can produce hydroxide ion in water. For weak acid and weak base, equilibrium sign is used. Weak acids are, in the previous point it is discussed, that is hydrogen sulfide, which is weak acid, hydrogen cyanide, which is weak acid, acetic acid, which is weak acid. So in case of weak acids and weak bases, equilibrium sign is used because in these cases 100% molecules do not ionize. So this is all about Arrhenius acids and bases. No more today. Thank you very much. Take care.